In 1964, a 17-year-old named Randy Gardner stayed awake for 11 days straight, no caffeine, no drugs, just willpower, as part of a science experiment. By day 3, he couldn't identify objects by touch. By day 4, he was hallucinating that he was a famous football player. By day 9, his hands were shaking uncontrollably. And here's the part that should genuinely worry you. Some animal studies suggest that if you truly never slept again, your body wouldn't just get tired, it would start to fail, organ by organ. By the end of this video, you'll know exactly what happens to your brain and body at every stage of sleep deprivation, and the surprisingly small number of days it actually takes to become dangerous. We treat sleep like an inconvenience. Something that gets in the way of deadlines, doom scrolling, one more episode. There's a kind of cultural pride in running on 4 hours of sleep, as if needing rest is a weakness you can train out of yourself. But here's the problem: sleep isn't downtime. It's not your body doing nothing. It's one of the most biologically active processes you go through every single day. Your brain is clearing waste, your immune system is recalibrating, your memories are being filed away. So when you skip it, you're not just missing rest. You're interrupting dozens of processes mid-task, night after night, and the effects start piling up faster than most people realize. The real question isn't, can I survive on less sleep? It's what specific things break first, and how fast. The good news is, we don't have to guess. Between documented human cases like Randy Gardner and controlled animal studies, scientists have mapped out sleep deprivation, almost like a timeline of dominoes falling. Let's walk through the 3 biggest things that happen to your brain and body, in order of how fast they hit. The first thing to go isn't your body, it's your brain, and it happens faster than you'd expect. After just one night of lost sleep, your prefrontal cortex, the part responsible for decision-making, impulse control, and focus, starts operating less effectively. Studies on sleep-deprived drivers have found reaction times comparable to being legally drunk, even without a single drop of alcohol. By 24 hours without sleep, your cognitive performance is measurably impaired. By 36 hours, your body starts producing more stress hormones and inflammatory markers, and your ability to regulate emotions starts to break down. Small frustrations start to feel enormous. Push past 48 hours, and something stranger starts happening: microsleeps. Your brain begins forcing brief, seconds-long naps, whether you want them or not, sometimes with your eyes still open. You're not choosing to fall asleep. Your brain is essentially staging an intervention on you. By the multi-day mark, like what Randy Gardner experienced, full hallucinations can set in, because sleep isn't optional for a healthy brain. When you deny it long enough, the brain starts producing dream-like content while you're still conscious. The second major breakdown happens somewhere you can't see it: your immune system. During deep sleep, your body produces and releases cytokines, proteins that help fight off infection and inflammation. Sleep deprivation research has consistently found that people who sleep less than 6 hours a night are significantly more likely to catch a common cold when directly exposed to a virus, compared to those sleeping 7 or more hours. Chronic sleep deprivation has also been linked to reduced effectiveness of vaccines. In one well-known study, people who slept poorly around the time of a flu shot produced fewer antibodies than well-rested participants. In animal studies specifically designed to test total, prolonged sleep deprivation, the pattern is even more stark. Without sleep, the immune system eventually loses the ability to fight off infections the body would normally handle with ease. And in extreme long-term deprivation studies in rats, this immune collapse was ultimately fatal. Your immune system, in other words, treats sleep as non-negotiable maintenance. Skip it long enough, and it stops holding up its end of the deal. The third effect is the one researchers find most alarming, and it's about something you'd never think to connect to sleep: your body temperature. In the classic rat studies on total sleep deprivation conducted at the University of Chicago in the 1980s, researchers found that as sleep-deprived rats approached the point of complete deprivation, their bodies lost the ability to regulate temperature properly. Despite eating more than usual, they lost weight and their metabolism became increasingly unstable. Eventually, in every case in that study, the animals died, not from any single dramatic cause, but from total systemic breakdown, as if the body had simply run out of ways to keep itself stable without sleep's maintenance functions. In humans, we obviously don't have, and would never ethically run, a study that goes that far. But the trajectory researchers see in extreme cases like extended sleep deprivation experiments and rare genetic conditions that prevent sleep, like fatal familial insomnia, follows an unsettlingly similar pattern: temperature dysregulation, metabolic breakdown, and eventual organ failure. The takeaway isn't that missing one night of sleep is dangerous. It's that sleep isn't a lifestyle choice your body is willing to negotiate on forever. So here's the full picture. Within a day, your brain's decision-making breaks down. Within days, your immune system stops protecting you. And in the most extreme, sustained cases researchers have studied, your body's basic temperature and metabolic regulations start to fail entirely. None of this happens because your body is fragile. It happens because sleep isn't a passive state, it's active maintenance, running every single night, on nearly every system you have. Here's something practical you can do with this. For the next 3 nights, track just one number, the time you actually turn the lights off, not the time you get into bed scrolling. You don't need a sleep tracker or an app. Just a note on your phone. Most people are shocked by the gap between "I went to bed at 11" and "I actually fell asleep around 12:40. If you do this, drop your results in the comments. I'd genuinely like to know how big that gap is for people watching this. And if you want more videos that take something you assumed was simple and show you the actual science behind it, subscribe. That's exactly what this channel is built around. So the next time you're tempted to treat sleep as optional, remember, it's not downtime, it's maintenance, and every system in your body is quietly counting on you to show up for it.